I'm going to play a little Halloween music. Let's see.
And then we
Yes.
Yep. We are live.
Our mic is live. I can come over here and I can shut down the Halloween music. And I see a beautiful face in front of me now, Ron Evans. Wow. Can you
Hello.
believe that we got the Ron Evans on the show today?
Crazy.
I know. We were able to pull him away
That
from his we pulled him away from his mad scientist lab somewhere deep in Spain. And to make an appearance. So this is awesome. And Ron did some cool stuff since we were last on the show. So I want him to show that off. And then we can show Ron sort of what we've been working on. Thanks to all his work on his, how do I pronounce that again? Zima? How do you pronounce it?
Yzma.
Yzma. I knew I was
Yzma,
saying
okay.
it wrong, but I was going to wait for Ron to help me. Yzma. Does that mean anything in Spanish or something? Yzma.
Well, Yzma is a character from a Disney movie called The Emperor's New Groove.
Oh,
Okay.
I think it's like 20 years old or something. Um, I watched that movie a lot with my son Manolo. Anyway, it's a character who is a witch who is running this empire down in South America, and the emperor is kind of lazy, doesn't really want to do any work. She turns him into a llama, she actually plans to poison him, but accidentally turns him into a llama. So I thought, oh, what a cool name for something that connects Go to llama CPP.
Oh man, what a great backstory
That is
there.
good.
Why haven't you shared that at like one of your conference talks, man? You should have started like a couple of slides like that. That would have been
Yeah,
cool.
I try not to flash any Disney logo type stuff,
Oh,
just
yeah, yeah, yeah,
because,
yeah, yeah.
Valid.
I hear you.
they
I hear you.
may or may not have a sense of humor,
I hear you.
but
I hear you.
actually probably not. I'm pretty confident from
Yeah,
prior experience.
yeah.
Good experience, not bad experience,
I
but
oh, yeah.
experience nonetheless.
All right, Yzma.
Yzma.
Yzma. Nice. Okay. So thanks to Ron, I got super busy again because Yzma has changed my life. And I've been using the show to hack on it. But before I show Ron what I'm trying to do and sort of where we're at, because I got the context window fixed
Yep.
um, uh, over the weekend or whenever before I left.
Hmm.
Let's see here. So Ron should be able to share his screen, right? How do I do that again, Kevin, with all
I
this
think we
stuff?
have the screen set up,
That's my screen.
and then one of them.
Is it working now? Can you see my screen?
Oh, we had a second screen share.
We have this one.
That's my screen.
That's your screen.
Let's see.
Okay.
Is that one Ron's screen?
So I think, yeah, this one is Ron's screen. So we'll go
So Ron
here.
has the same thing on I have. Doesn't make any sense. Oh, that's Ron's screen.
Yeah.
Okay, hold on.
And
We
then
just got to
here
set this up.
we'll put, oops.
Oh,
Why
we
did
just went
that?
backwards. Ron's screen. Okay, good. We got Ron's screen up.
We have us here. Of course, it deletes the wrong one.
It's okay, don't matter. And we come up, and then Ron comes up there. This stuff I've learned.
No.
Ooh.
It's wanting to, let me see.
Just got to create another one of those.
Yep.
All right, we're almost there, Ron.
No worries.
I can't see like the,
Yeah. Yeah, the X is there. Or the edit there.
and then this will be Ron.
Okay.
There we are.
All right, we're good. Okay, so I got Ron. Double click to pick. I don't know why. Okay. Why do they have these words over Ron's face?
It's stuck there.
Okay, whatever. Okay, so Ron, you're now sharing your screen with the world, and I'd
Cool.
love for you to show what you just did with Yzma and the Go um, CV project that you've been working on Go CV for a couple of years now, which is pretty wild too.
Yeah, quite a while. Um, Actually, I believe GoCV is
But nobody sees
9 years
it.
old now. Let's throw up the GoCV repo since we're so yeah. It's so if you don't know about GoCV, GoCV are the wrappers for Go and OpenCV. OpenCV being kind of the gold standard for computer vision. Basically, I think it's 25 years old. Runs on everything, Android, Windows, Linux, Mac OS, other, embedded devices of different sorts. You can compile it to WebAssembly, um, and it has probably thousands of computer vision algorithms of different sorts. I mean, I don't know the exact number, but it's a very large number. Generations of graduate students. So GoCV are wrappers for OpenCV from Go, which let's see if I can see anything that might lead me to think when it was started without. I saw something that said like 7 years. It's at least 7 years. Um, has over 7,000 stars, 150 contributors. Um, so you can do a lot of cool stuff with it with computer vision, some of which also use deep neural networks, generally convolutional neural networks, to do things like object detection, object tracking, um, classification, using a variety of computer vision models that are trained in different ways, generally in the ONNX format. So, um, so that's what GoCV does. And the thing about why I started this ISMA thing was I wanted to be able to do computer vision processing, not just with traditional convolutional neural networks, but also with a thing called vision language models, which I don't know if Bill, you've talked about that at all on any of the previous shows.
We did we do anything with the vision? I've had a hard time with vision language models, Ron, because I've always so Florin and I are struggling with the vision, not vision language, just vision models in general. No,
Yeah.
I've never played with vision language models. Well, I
Ah,
shouldn't say that. I shouldn't say that. So Florin and I have been struggling because we've been wanting to use the vision language models to um, well, we use it to extract code out of videos, right? So that's worked out really, really well. But we were trying to use them to compare videos at some sort of similarity level, and we were having also actually no, those were embedding models. I am
Yes.
so confused, Ron. No, we've done very well with vision language models. We've done very poorly with embedding vision, embedding image models. That's where
Yeah.
we've just fell down flat. So I just completely destroyed the show by not remembering where we're going here. But keep going, Ron. I'm sorry.
it's actually super interesting because I wanted to ask you about that. So, oh, foreshadowing. I love it. Um, so yeah, I don't have like a slide or anything. If you actually, I don't know if those slides will make any sense. My slides usually don't make any sense if I don't actually give the talk related to them. So when I put them online, it's sort of like, wow, what does this mean? It's a single sentence or a single image, you know. So I probably need to do some diagrams, but actually some of the best diagrams are on Wikipedia. Let me see if I can find, because I was just looking at, let's see, Wikipedia um, vision language model. Because I was actually just noticing they had a very good, well, this goes too far, the vision language action model, vision language model. I don't want to jump the gun.
Did I
Well,
just
they have a
jump us
pretty
off
good,
that?
No.
so this, so the Wikipedia page, among other things,
What did I do,
has,
bro?
can you see this? Hello? Still there?
Yeah, no, I'm here. I mute because we have a little bit of an echo, but I hit a button
Ah,
and I do what I.
well, this kind of shows the general idea um, behind what is a vision language model. So you've probably played with language models a bit already on the show. Maybe we should start with language models.
No,
Um,
I've talked about all that, but I think this is a good
okay,
place to go so you can do your
okay,
demo because I think the demo that you
all right,
have now is cool.
okay. So, so you play with language models where you have some sort of text and you tokenize that, then turn that into a batch and pass that into the language model, and then decode that response, then taking each of the tokens that are being produced, using some kind of sampler usually to figure out, what's the most likely next one, and then producing a response. So the vision language model is the same idea of a transformer, but then adds another part to it, which is you have an image, which is then encoded in some fashion, and then that through what's called a projection, which is like similar to a tokenizer in that it converts the image into tokens. And then also you've got your text, like what do you see, for example, then the language model part takes and tokenizes that, and both of those are passed into the vision language model, which then does whatever it is that you're trying to get it to do, which might be description of what's in the image. It might be how far away are the things in the image. For example, models that are trained for different kinds of robotics applications. Um, there's a number of different types of applications for these things. It could be for classification. It's very interesting to use vision language models for classification. Quick sidebar on that. So people have been using vision models, convolutional neural networks for classification problems for quite a number of years. I did a bunch of years of it at Intel, in C++ generally and Python, later in Go. But these types of models, the thing about them is they can only really classify things they've already seen, what they call, you know, one-shot classification, where this thing that I'm seeing is very similar to another thing that I've been trained on, so I can recognize it to be the same thing. Vision language models can do a thing that's called zero-shot classification, which means it can see an image it's never seen before and try to identify what class it's in. Wow, how is that possible? Well, it's only possible to a limited extent. Let me just say it's not completely always accurate depending on what you're asking it to classify. But the reason it's able to do so is because what you're seeing in this, both with the image part and well as some sort of text that's associated with the training of this classification model of saying, oh, this is an image of this celebrity, and this is an image of this other celebrity. So show you a third image and say, is this person a celebrity? This is not saying, is it a specific one, but do they have that look, quote unquote? How that can happen is because we've associated some type of semantic knowledge with the text part of the model, along with the vision part of the model when we're doing the training of it. So it's really, really interesting for all kinds of different applications, not just the one I'm about to show you, which is kind of the traditional type of application you see with vision language models, which is captioning. How are we doing so far?
Everything's perfect.
Sweet. So, captioning of images is probably the hello world of vision language models, just because it's the thing that you always see. Similar to um, like face tracking, you've seen like a million images and videos with people with squares over their faces. That's like really, really canonical, you know, deep learning applied to computer vision. Well, captioning is the same thing, but it's for vision language models. So I thought, wow, I really need like a simple demo that shows how to do this without, dragging in too many moving parts. That way you can sort of see how interesting it is if we put together an application that is to do this. And of course, I thought it would be even better if we could stream it to a browser window. That way we could, get all the browser layout stuff. So I whipped together this demo earlier today um, that I call VLM Caption. So it basically uses ISMA and GoCV, uses GoCV to do the video capture part, and then uses ISMA to then perform the captioning. And you can see in this image, this is what we're going to end up with in a minute when I run it. the browser window showing a web page that's served up with live streaming of whatever the camera sees and then live captioning. So let's dig into some code. So this is the main function, the usual go main. We parse some arguments here, which are going to be the camera ID. With GoCV, we can choose multiple camera inputs if you have more than one camera. I have two cameras, one that is doing this live stream, and then another one that I've separately connected. That way I don't have to interrupt the main camera in order to bring up the other camera for this application. Then what host you're going to run it on. This is if you wanted to, for example, use a proxy of some sort and make it, so it was on the internet. I'm not going to do that just because I don't have the right setup right now. Um, the model path. So a minute ago when I was showing the vision language model, the way that that's actually implemented is that there's two different models. One, which is the text part of the model, and one, which is the projector for the vision processing that's separate. And then whatever prompt text. So we parse those. Then we open an mjpeg stream. So this is a package I created quite a while ago called mjpeg, which I think I haven't made changes to it for quite some time. Oh, wait, 8 months ago. All right. I take that back. I fixed something. Sweet. Um, as you can see, it's a fork from another mjpeg streaming project that, as I recall, I forked it because this was abandoned quite a long time ago. Um, so what it does is it lets you do a motion JPEG stream and then serve it up through the normal HTTP muxer that you use with Go. So motion JPEG is the same format as static, still JPEGs, but it includes multiple frames that are served up in order to create an actual video effect, which is actual video. So it's supported in pretty much every browser. I mean, even really weird ones for a very, very long time. And you just serve it up. You don't need like a video player. It's just an image that happens to be video.
So
So we
wait,
open.
wait. This is just serving up JPEGs that are how many frames a second already written to disk or something?
Well, in this case, it's live streaming it from my camera.
Okay, so your camera's producing a JPEG, and then this is just streaming it down the pipe.
But we'll jump into that in a second. I'm just saying this is an HTTP streamable MJPEG stream. So then we start the video capture. We pass in the device ID, which is which camera we want to use, and then that stream we just opened. We have to do that because we also are going to need that stream in a minute in order to serve it through the web server. So let's take a look at this start video capture. This will make it, I think, a bit clearer. So start video capture, it opens up your webcam. It then creates a mat in GoCV. The mat is kind of the fundamental unit of data. This is because OpenCV has a thing called mat, and GoCV is just a wrapper around it, which is a matrix of data generally representing an image. In this case, it's a 2D matrix of bytes representing the red, green, and blue bytes of the image as it's coming in. And then we call this function capture frame. Capture frame, we have a mutex because we're going to need to use this image in order to pass it to the vision language model, and we don't want to capture at the exact same time that we're copying it in order to process it in the LLM. So the easiest way to do this for the point of this demo was just to use a mutex, because we only want to have a single image at a time. We, in this case, we don't want to overlap the processing. Well, actually, we really are overlapping the processing because the bytes get copied by um, ISMA by itself. But in any case, we read from the webcam to get the image into that image mat, and then encode it into the JPEG format. And last, pass it into this stream, the bytes that we just encoded into JPEG, and then close that buffer. So we do this every time that there's a frame coming in from the camera. We stream it by converting it into JPEG and then passing it into that stream. Let's take a quick look at the server, just so that we can see the other side of this. So the web server, it's got an HTML page that we've embedded in, which is what the user interface is. Then we start the web server, again, passing in that same stream, right, the one that we're capturing into. And this way, we can say mux.handle, we're just using the normal HTTP standard library server mux. We're saying, oh, the mux handler for this should be that MJPEG stream. So it's really, really easy to set up a route that streams whatever the latest MJPEG video image is.
Is that
Then,
done like over WebSocket or SSE or
no, it's just part of the motion JPEG.
just when you're sending that to the browser though, that's being pushed, right? From the server to the browser?
Yes, because the browser knows if the image tag is smart in browsers. The browser looks and says, oh, it's motion JPEG data. I better keep fetching it forever.
Oh, you're gonna do an image tag. So the browser's making that call.
Yeah, let's jump over there and look at
Oh,
that page
yeah, I've
just so
never
we can
played with
see.
that. I thought you'd have to
Interesting.
set up some SSE or
That's what I was thinking too.
oh.
I'm a very, very lazy man. Um,
Welcome to the club.
Now, there are probably more efficient, not probably, there are more efficient ways to send video data. There are more sophisticated ways, but there is surely no easier way. And also, it's an ubiquitous way. I mean, every browser supports this, right? Like the image tag accepting motion JPEG, it always works. Versus video players where, do you have the right codec? Do you need to install some type of player? Is it just pure JavaScript? Is it some WebAssembly? So um, anyway, I digress. So this is the HTML page. Um, it's got just a couple of styles so that it, looks nice. But the meat of it is we've got a div with the image container, and here's the image, which is getting the localhost port 8080 video route. That's it. This is the other side of it. It just gets displayed.
Can you show me the go side of that handler one more time?
Yeah, that's this.
Yeah, show me that. Oh, and this.
So
Yeah.
we pass in the MJPEG stream. So let's go back to.
Can you show me the I want to see the stream.
How's this working? Damn it! How's this go? Um, so when we first, actually, let's jump back over here real quick to the main because we started it out. We said, okay, we're creating a new stream. So new stream, it's got a channel of byte slices because we need to be able to, you know, um, get the raw data. It's got a byte frame. This is the current frame that's going to serve up. the interval at which it's going to serve this up, by default 50 millisecond, but we can override that, and then a Go standard library context. That way, this could be interrupted if you want to use the other variant, which is new stream with context, and pass it in. If you were trying to do a motion JPEG stream as part of a larger application, you're going to probably want to use this form, just that way, whatever your normal logic is for clean shutdowns or, you know, wait groups or whatever you're doing. So motion JPEG has, some magic bits, a magic boundary word and header, and then our serving function, all it does is send that data, in the stream of the HTTP request, sending it as part of its response, and we just, at the interval, we go and we say, oh, write the latest data so that the stream recipient gets whatever the newest frame is.
So that connection is held open via this loop.
Exactly.
Yeah. Okay.
And then the function I called in the video function to update the JPEG, all that does is update the frame data and then send that to all of the connected clients. Right? Because remember, it's an HTTP server, and we need to be able to send the data to all. There could be multiple web browsers connected to this, right? I mean,
Yeah. So
common
you're basically
use
getting a
case.
frame. You're sending that over that channel. That loop then goes boom, and it gets sent. Is that you're using an unbuffered or buffered channel there on that? It's interesting.
So if we go and we take a look at the channel I'm using, um, so this is not it's actually a map of channels because there's one channel per connected client. Whenever a client connects, then where is that code?
Yeah, line 63, you're constructing the channel. So you're using an unbuffered channel. That way, the other side blocks until this side is ready to send it. And yeah, keeps it simple, man.
Yeah.
Yeah, nice.
Anyway, back to
Okay.
so all of that is just handled within the MJPEG stream, and this route just exposes it so that whenever stream is updated, which I did in that video, did I show that? Yeah. Um, when we capture the frame, we read the frame, we encode it into JPEG, and then we update it.
Yeah, and that does all the magic, and the browser's waiting for it, thanks to the
Exactly.
way the image tags work, which is really wild.
Yeah.
Who knew?
So back to the main function. So this is, sorry, got to tell Ava I'm on the phone.
They saw you live. They got all excited. They wanted to call. So this is pretty cool. Like, I didn't know the image tags worked that way.
I
Like,
didn't
all
either.
magically. You don't have to do. I mean, there's no security behind that, really, but just to do what
Well, there's
Ron's
whatever
doing.
security you would have through whatever proxy or whatever gateway you would set up through. I
True.
mean,
With the header, with a JSON web token, you can still check it. Yeah.
well, I mean, in this application, you know, all we're doing is, setting up the normal server mux and then serving that up. But you could add whatever middleware you wanted to in your own
Right.
application,
Right.
to do whatever type of authentication or, processing you wanted to do. So, Um, anyway, so we started our video capture, and we're getting those. Um, so we also started Go routine to do the processing for our vision language model. So this is the really interesting part. Um, so you've seen some of this probably in previous, where you've been looking at how ISMA works, that um, we load the dynamic libraries, which are the latest or whatever version we have installed of Llama CPP, and then we do the same thing for the MTMD package, which is a part of Llama CPP to do the um, multimodal. It's kind of a clumsy uh, abbreviation, but like I've seen people say multi-model lately, and I'm like, oh, I read in multimodal, and I looked. I'm like, no, it just means you could use different models. I'm like, yes. Oh, okay. No, I meant multimodal, which means both images and text, or audio and text, um, which is actually supported now with the latest ISMA release. If you wanted to do some type of uh, speech to text or something, you could do that. But I'm focused on video. Um,
But let me ask you a question on that one, because that was that second file that you have to download on one of the examples that I was putting together with your stuff. Which one
well,
was
this
it?
is just loading the multimodal dynamic library separately. The reason is that you may not want it. If you're just using language models and not vision language models, you're not going to need the multimodal stuff, so there's no reason to bring it in, right? That's why these are loaded separately.
So on the example you had where you were using a vision model in the native app, you made me download the MMPROJ version
Yes,
along
we're,
with
we're
the
about to
model.
get to that. We're about to get to that.
Yeah, I need to,
So,
because never when I'm
yeah,
working with Olama or something do I have to worry about downloading two files. So I was kind of curious what that was. Yeah, when we get to that, I'm kind of curious what that is and why we're dealing with that manually.
I mean, Olam is actually doing the same thing. It's just doing it behind the scenes where you don't see it
So
because it
if I
sticks it
pre-down,
into a single file.
oh,
Um,
when I tell Olama to download something, it's downloading all that stuff. I don't even realize it.
right.
Oh. And then when
It's
I
getting a
tell
whole
it to
bunch.
list all the models, it's just showing me the one model,
A high
even with this
level
file.
list of the actual, like,
Ah,
it
okay.
doesn't show you all the gory details of all the files that are included there.
Okay, I didn't realize that. All right, cool.
Yeah, Olama uses Llama CPP under the hood. Supposedly they're working on a new multimodal engine, but um, at least at this point, they're still using Llama CPP for all of the, lifting, not just heavy lifting, all the lifting. Um, I mean, now they are doing a bunch of other stuff, right? Like, for example, the thing you just mentioned, Bill, hiding from you a bunch of gory details about that you actually have a model file and a projector file separately that you have to download. Like with Olama protects you from having to have that information, for example, and some other things. So I mean, there is definitely a convenience aspect, but if you want raw power, this is the way to go. Um, anyway, so I turn off the logging just to shut it up, and then llama.init is a function that just initializes the main llama um, library. This just loads it. This actually does the initialization. So now we're ready to go. And in this application, I created a type called VLM to try to make it a little more clear about exactly what was going on. So the constructor for this new VLM function takes the model file and the projector file as two separate parameters. So that's the thing we were just discussing. If we go and we just look at all that's doing is just saving those for us to then use them when we call vlm.init. So vlm.init is this function which says, okay, first load the text model file. Then we set up some context parameters and initialize that same text model. So, like you've discovered by using it, the context is really important in Llama CPP. That's what maintains our current state.
All right,
The
now
models,
I'm going to
the
interrupt you for a
definition.
second.
Yeah.
There was another context parameter that I had to set to properly set the context window. That was the NU batch, which represented the physical
Yes.
maximum batch. Until I did that, I couldn't increase the actual context size that the model was, or I guess Llama CPP was using. Have you run into
Yeah.
that problem?
So it turns out that there are, oops, wrong directory, sorry. There's a lot of parameters that you can set that you may or may not need to depending on your particular situation. If we go and we look at the type for context parameters, I believe you were talking about NU batch
Yeah,
just
I
now.
needed to set both NU batch and N batch to get the context window to work properly above the defaults.
Yeah, I mean, there's quite a few parameters here that have some really powerful effects that if you don't know what they do and that you might need them, and that's kind of just sort of this is one thing about Llama CPP. It's a very low level library. It's intended for you to use if you're using just the package itself, to kind of build your application from these pieces, as opposed to like having a web server which is doing all this stuff for you and translating it in whatever means necessary to send you back the result. So you can get much more efficient operation, but as you discovered, you may have to understand things like that there is a difference between the logical and the physical batch size, um, having to do with the way that it's able to store how much of the context window at once, I believe.
Yeah,
Um,
I needed to increase the
there's a
physical
lot of,
maximum.
yeah, but I mean, like things like pooling type, you need this only if you're going to try to do embeddings. Oh, and if you don't set embeddings equal to one, it won't actually do embedding.
So I have it doing embeddings without having to set the pooling type, which I guess I just let it use the default because I didn't understand. I'll show you that when you're done. Let's go back to that when you're done because I'll show you my sort of example that
Sure.
does that. I was just curious why you were not setting a new batch on all your examples, but I guess if you're not going to go beyond the default
I'm sorry, my
physical.
Ava just came home with a puppy.
Perfect timing, so you can't take
I
the
know.
puppy back.
Yeah. All right. I'm talk about wait. What was I talking about? I
I
don't
can't
know.
wait to show to tell Ali that. I guess
Oh
I
yeah.
guess what I was saying, none of your examples set the NU batch. So my guess is if you stay within the default physical size of that window, right? The N batch is just setting it within the scope of the default physical size. But on the
Yeah.
embedding model I downloaded, like 512 ended up being the default size. So anyway, it doesn't matter. I'm just
Yeah.
there's a
No,
lot of
it's
stuff
it's
here.
interesting stuff that like different models also will have different parameters. Um, Actually, that's something that's kind of worth seeing. That was a feature I added to the most recent release of Yzma because it was really annoying me. Was I wanted to know what were the different parameters and stuff in the model, so I added this model info command that I can now run that will show me some of the details for example, all the different metadata, the chat template, um, the
And
vocabulary
this
size.
is what Hugging Face shows on that model card, right? But you were able to get it
Yes.
out of the model itself now.
Yeah, um, the GGUF format actually contains all of this metadata inside the model file itself. So I'm able to query it from Yzma and just display it directly with nothing more than the GGUF file.
Yeah,
Just
so
because
I
that was
see
something that
like
was
yeah.
really annoying me. I'm like, wow, I really need some of this data, and like I'm trying to figure out where can I find it. Where did I download this thing again from? I'm like, okay, actually, it's in the file. Oh, whoops, I should just use it there.
Yeah, that's
Anyway,
smart. That's smart.
um, but yeah, the context params defaults are usually kind of sensible defaults, but you may very well need to set them to something different. And these settings I use are very arbitrary. Usually you might want to actually look at the model itself and figure out based on what it's set to, you know, you want to have a batch size maybe set and context size that are the same because that's what it was trained on or things of this sort. So you kind of have to be familiar with the model itself and looking at the model card on Hugging Face. Usually, if you dig around, you can find some details that maybe tell you some key information to getting it to work better as far as results or work faster as far as performance or both. Um,
And I guess when
so
it
once,
says use 0 for the default, it's pulling the metadata out of the model and using those numbers.
yes,
Yeah, okay.
exactly. Anyway, once we have our context parameters, we then initialize the context itself, which is, our runtime set of values of the model is just the definition of here's what you should do. The context is here's what we're actually doing right now. And then also initialize a couple of other things we need, like our chat template. So a minute ago, we were noticing that there's a chat template inside the model itself, which is
Oh,
really,
I didn't realize that.
yes, that's where that's coming from when we say um, the llama dot model chat template function, which is part of Yzma and part of the llama CPP API. It's actually pulling that out for you.
I was wondering about that because you had an example where I think you were like setting a template and I was like ignoring like in one example you don't do it and my brain was like how's that working? So now this makes perfect sense. Huh.
That's why I'm passing in an empty string that says use whatever the default template is for the model,
What
which is usually
where's this code, Ron? Go back to the other screen.
which
I
one?
want that code. The code that's dumping the model metadata.
Oh, that's in the latest Yzma
Ah,
in
okay. So if I pull
the
latest, I'll see
examples.
that.
Yeah, under examples, model info. And I did not dump everything. I was maybe a little lazy. Um, I only dumped some of the high level stuff and all of the metadata. I did dump all the metadata, but there's some things like the batch and context size and stuff. You could dump those as well. If you need that stuff, you could submit a pull request, and I would surely accept it. Just because I threw in these, and I just like, okay, cool. I'm gonna get to the metadata, and then all right, done, ship it.
Yeah, but what you're
Uh,
showing is pretty much what you need anyway to see what's going on.
yeah, you might need a couple of those other parameters, or you might not. I didn't need them for anything yet. As soon as I do, I'll add it. For sure. Um,
I want to add an
anyway,
example of that for sure too. Yeah. Okay,
yeah,
cool.
no, it's. I was thinking how handy a browser would be, like a TUI, where you could like look at the directory of files and oh, it's a GGUF file. Let me try to get the model info and then display it and look at the pane or something. And that would be a cool thing to have. Something that was real nice looking because it used charm or whatever. Um, that'd be really cool. I have not done this. It'd be nice to have. Um, all right. So the template, then the sampler. So the sampler is a thing that it's kind of mysterious to a lot of people. Like you don't realize what's going on. And this one line is like really hides a lot. It just says create a new sampler with all the default samplers, which are actually a lot of samplers. If we go and we take a look in Llama sampling, we can see that the default, where's the default samplers? I have a list somewhere.
I mean, like I'm clueless changing whatever the default is. Like,
Well, it's not just one sampler. It's actually a bunch of samplers. Let's see. Where is that? Oh yeah, default samplers. That's right. No, it's in there somewhere. So the default, so samplers are what look at the current context and try to figure out what is the next token it should produce, or a group of tokens, if it's set to produce a batch of tokens. But most of the time, it's just producing the next token. So the simplest one you could possibly have is the one that's in the hello sample, which is it sets up the default sampler chain and adds a single sampler, which is the greedy sampler. Greedy will just take anything, like whatever's the next one. So it's
in
not
the
very accurate.
in the chat example, I see that you had a sampler chain add with top K, top P, temperature. Okay. So this is
Yeah,
like
that one in the chat example, I used only a small subset of the possible samplers because what I wanted was to simulate or duplicate, better said, what the Llama CPP command line params do when you pass in a flag, it then brings that sampler into the mix. So if you don't pass top K, or if top K is equal to 0, then it doesn't use the top K sampler.
does the
Now it's
order matter?
um the order does matter, but you may want to change that because of something you're doing that you know what you're doing. You might not. That's the reason why I did the default one, just because my assumption was, yeah, I'm actually like, wait, how did I put it? Ah, here we go. For like the typical case where you want the kitchen sink of samplers, you want all these samplers, and you want them all with their typical default parameters. So this is the reason why I created this, you know, smorgasbord of the default samplers, which is what I used here, just because that's kind of if you want to do VLM sampling, that's the most likely case. Now, I do need to add a way to set individual parameters and still use the default samplers. I have not done that yet. That's the reason why the chat example does the initialization that it does is, oh, I actually wanted to pass in specific parameters. It wasn't that I minded those other samplers being in there so much as the fact that, oh, if I don't have an easy way to override their value, then, it might cause the chat to not produce what I'm looking for.
Yeah. No, I hear you. Now
So
I understand.
that was
But
the reason why.
you need some sampler at the end of the day. Something.
Yeah, you have to have a sampler because otherwise you have no way to be able to pick what is going to be the next token to produce as part of whatever the generation is. So then we set up our MTMD context. So this is because we have a context for the text model, and we also need a context for the projector for the image. And this, by the way, it's actually the context that combines the image and the text model to produce this final result. It's kind of the combined context. So we call the MTMD init from file, passing it in the projector model file, which is that PROG file, the text model, which we already opened and initialized, and then the parameters for the multimodal processing. That was a lot to do, but now we're fully initialized. Our VLM type is ready to go, so the rest of our work is a lot simpler. We create the prompt, which is whatever we passed in initially, how we wanted to describe each frame. One thing that's worth noting is we add to that prompt the MTMD default marker, which is usually something like image. We could actually, can we see that anywhere? Maybe. Let me see. I'm not sure if I have that. No, I only use the default coming directly from Llama CPP. But it's usually a tag that gets inserted into the prompt text that says there's going to be an image here. The reason why we need that is that when we actually go to create the message, we have to insert the image so that the model can go, oh, here's the image you were talking about. Maybe you pass in multiple images. Like you could say, how describe the difference between these two images, image one, image two. So you need some way to be able, in our case, we're only going to pass in a single image. So all we have to do is add a single marker.
And the prompt in
And
that case is an empty string, right? Because you're not passing in a special prompt or anything. So
the
it's
prompt
just,
is whatever we pass in when we run the command.
right. But you don't
So
have
like,
to have a specialized prompt. It will still work.
well, you have to ask something for how it's
Oh,
going
the
to
prompt
describe
is the
it.
question. I'm sorry.
Right.
Okay.
Like
The
in,
prompt is the
like in
question.
this case, I'm going to say, give a brief description of what is going on.
Okay. Yeah, right.
Right.
Okay, that's the question. And
Yeah.
then you're going to add the marker, and then it's going to be the image that comes.
Well, that's going to get inserted. You'll see in a minute. This is just to say the prompt is that question plus the marker to say whatever image is, because we're going to reuse the same prompt every time because we ask the same question just about the latest image. So then we'll call this function next caption. Next caption says, let's create the chat messages slice, which is just the user asking that question. Then we'll create the new input text that's we're going to pass in to the multimodal context using the template, the one that we pulled in the default template from the model itself, and then passing in the messages array, which only has, or slice, which only has a single item in it, that one message. These true, this says, do I want to append after the prompt the prompt to tell the model to generate something? Because if we don't tell the model, okay, your turn, it doesn't answer. It just waits for you to keep talking to it. So this is just that
Oh,
way.
what's the name of that parameter? Because I think that was confusing me on
the that's about adding the assistant
Add
prompt
assist prompt. Okay.
because it's the assistant, presumably,
Gotcha.
right? So this is just saying we want to add the
Mm,
assistant prompt, and
gotcha.
then we also pass in true and true of saying do special prompt handling, or sorry, do special token handling for tokens like the end of generation, meaning I'm done, or any other special tokens that come flying through. Um, Parse them and then also add any that you need. Just this way, the input text ends up complete. It's like the whole thing that we're going to need, except for the image. So then we need the image data. For that, we're going to call this map to bitmap function. So map to bitmap was a function that was defined in video.go here, and that takes the latest image coming from the webcam, which is a gocv.mat, and then we take that image, right, we're passing it in, so we create a new mat to hold our converted data because we want to make the job of the VLM easier so it can actually process data correctly and give us a correct result. Because if you pass in like random binary data in the wrong format, it may or may not be able to convert it. But if we pre-convert it, then we end up with data it can actually process well and also quickly, as you'll see. So this is just allocating a new mat to hold the data that we're going to convert into RGB format. The reason we do this is that OpenCV stores data in BGR format by default. So if you were to look at an image with BGR data, but in RGB, it looks like kind of weird, like chroma key type effect. Whereas if we convert it, it actually
You're right.
looks like the
Oh.
image you expect it to look like. And since that's what the model was trained on, that's what we want to pass it. And then,
BGRT is a new. I've never heard of that format.
well,
Huh.
BGR,
BGR. Oh, BGR2. BGR. Is that just blue? That's not like
yeah,
blue, green,
blue,
red to
green,
red.
red
Oh.
instead of red, green, blue.
Uh-huh.
That's because OpenCV has been around for so long. That's actually a very common composite video format. So
So it's like you're just
it's been,
flipping bits. You're just flipping bits to
yeah,
change the
pretty
order.
much. I mean, this conversion, yes. There are other conversions that change to other color spaces and stuff, but this is a very simple one. It's literally just moving the order of the bytes. And then we're getting a pointer to that so we don't have to copy the data again, right? Because we're trying to do this as quick as we can. And then last, we call the MTMD packages bitmap init. So when you saw the VLM example previously, let's open that real quick. We're using a different function, which was bitmap init from file. This is reading in a file from disk to do it. Well, in this example, we already have it loaded in. It's in memory. We're just saying, use this bitmap that's already in memory. That way it's really, really fast, right? Because we don't need to copy the data. We don't need to allocate more memory. We literally just say, use this data starting here for this much, for an image of this size. So it's really, really quick. That that right there is like why I did all of this was pretty much just to do that. Okay. I mean,
Yeah, I know. All
like
this setup, all this
all
preamble.
of this, like months of work, and it was all just to be able to do that. So yeah, you're welcome. No, no, but seriously, it was like you really need that to do the kind of performance that if you want to do any kind of decent throughput of processing this stuff. Um, so we have to free that data at some point. We just do it, when we exit this function. Then we allocate some chunks to hold our output because we need a place to put the output. And then we tell the VLM to tokenize, passing it in the input text, the bitmap that we want to have stuck in there, and then where to put the output. So VLM tokenize is just a very thin wrapper to call the MTMDs tokenize, just because it can take a slice of bitmaps, and we only have one bitmap here. Otherwise, we probably could just call it directly, but yeah, whatever. Um, where were we? Oh yes, next caption. So we tokenize. So now the output's got our
Let me
stuff.
ask you a question about tokenize. Is that
Yes.
is the tokenization part of the model, right? Like the model has a tokenizer that it was used, or is this a Llama CPP thing?
Well, tokenization is a process that is done by transformer-based models. And if we go back to a look at our um, schematic here, right, that the tokenizing is taking this input data and converting it into tokens that our model is going to be able to process. Now, tokens are like a diction, it's like a map that maps something to something in the model. Like, let's just say gophers are all cool, right? The sentence. Let's just say we wanted to tokenize that and make a dictionary of 4 items. So ID 1 would be gophers, the word. ID 2 would be are. Token 3 would be all, and token 4 would be cool, right? So that's our full dictionary. So if I pass in all gophers are cool instead of gophers are all cool, it would just be able to look that up in the dictionary and be giving me those tokens in a different order.
I guess what I'm asking is for different models that we've loaded, we're going to get different tokens for the same say text.
Ah, so very important to understand um, when you're working with text models in particular, right? But is that if we look at the chat example, this is maybe easier to follow. Um, that when we are going to tokenize the text with just a text model, we have to pass in the vocabulary to use in order to tokenize it. The vocabulary is part of the language model that's like that dictionary I was just mentioning. It says this word is this token, and this word is this token, and this word is this token. Maybe it's this concept is this token, right? But that this thing maps to this item. That
Right.
way I can convert some input into a vector of tokens, which is the thing that has to get passed into the model. So in this case, we are using the MTMDs tokenize, which has to do both tokenization of the vision encoded projection and the text. It has to do it at the same time. That's why it's a single function, which calls into the MTMD packages tokenized to do its work. We don't set up a separate vocabulary to do this. This is part of what's handled by the multimodal models. You don't
Okay.
have to
Yeah.
do a
Okay.
separate.
I get it now. Yeah. I remember seeing the vocab for some of the other
Yeah,
examples,
that's
passing that
that's
token.
only for text models. The multimodal models, um, you follow this procedure for it, then does all of this work for you inside of Llama CPP, where it does what you're seeing in this diagram, right? Okay, tokenize the text, you know, uh, convert and tokenize the vision input, which could be images, could be audio, could be video. Not currently, I don't think, with Llama CPP, but you can with other transformer models if you use Python. Um, I think you can do this. Sorry, I don't think you can do this currently with Llama CPP. I know you can do it with Python with the transformers package. Anyway, so this is doing under the hood all this work in order to do all that converting for you, just because you've set it up. And then last we get the results. So the results is a loop, of course, that has to go through and calls this helper function, which does the same thing in reverse of saying, given the context for the projector and the context for the model, right? Because we need both the vision part and the language part, take and put into this output, which is strangely called input chunks. I don't know why. Probably they should have called it output chunks, but since Llama CPP calls it input chunks, I just tried to stick with it. But that's where you're putting the output. And now that we've got that output, now we can go through, batch it up, and process it. So this is where
Can
we're
you
about to
can
see
you
the.
talk to us about what a batch is? Because it's
Yes,
such
this is
a
a thing that is super confusing to a lot
yeah,
of people.
it's such a blown up word,
And
you
like,
know.
once again, Wikipedia. Let's see. Um, oh wait, sorry. Transformer. Wikipedia has everything we need to know of every subject. It's really cool. Let's see. Uh, um, shoot. I had this before. Maybe it's in my history. Digging through my history, it could take forever.
I'm
Um,
glad Ron can read this page.
uh, hmm.
As
Let's
soon
see
as
if
I
I can
see an
find.
integral or something, I'm like, done, dude.
Yeah, I know. I used to love more maths. I forgot.
Kevin,
Um,
did you do any of that math when you did
I still know
calculus and all
some
that stuff?
graphs. I still know some
Mm.
graphs, which it turns out are really helpful when you're doing all this stuff. But I forgot most of my maths. Um,
Allie's really good at this stuff, man. I show Allie that she'll just like disappear for 5, 10 minutes and come back and start explaining. And I'm
well,
like,
it was.
dude, just hit Control F. Can't you find? What are you looking for? The word batch? Oh, that's
Well,
your image.
the important part is when you're processing tokens, you don't process one token at a time, generally. I mean, you might, right, if it's a batch size of one, but it's a lot more efficient to pass in a group of tokens at once. Like, for example, wouldn't it be better to pass in the entire question all at once in a single batch,
Seems like it.
for example? Or don't you think you need to pass in the full image as a single batch? Because if it's only got like a few pixels of the image, how could it possibly? It can't really do any processing that's at all useful, right? So the batch size is basically saying we want to process the correct size of tokens all at once that we can in order to produce the results that we need based on however the model works. So in this case, we're saying I want to create a new batch that has got only really a single item in there and starts at 0. So I probably could have used the function that's called
Well,
batch.
that first
Probably could have
parameter.
used that batch get one.
Or
Um, I probably could have used that function instead here because it in fact is nothing more than a batch of size 1, right, that I'm allocating initially.
I guess what's
And
confusing is that when you hover over that, it says end tokens. So I'm thinking like you're processing a batch of one token at a time there.
yes, but you'll see what's going on in a minute, um, because this batch is only the batch in order to um, decode the thing that we need. Um, because we've already encoded everything as a part of this helper function. It's already done all the encoding part that we need. So now all we need to do is get the results. So this is saying we're going to get our results in a batch of one token at a time. And then here's where we bring in the vocabulary in order for us to be able to say, oh, the results coming from the model, how do we translate those back into something we can read? We need to have that dictionary, to look up what each token means. That's what our vocabulary is. And then the results are, here's where we're going to put, the full sentence. So we start looping through for as big as the maximum number of results we can accept, right? Like this is a very large number, but that's because generally they only produce a very small group of results because of the way that the model's temperature is. It doesn't just keep going on and on. So in this case, I set it to a very high number. That way I get the full set of results, whatever they are. So then we sample. We say, give me the next token using the sampler that we've set up and the model context, because this is the results coming back. If it's our end of generation token, great, meaning the model said I'm done. Otherwise, allocate a buffer to hold whatever word that token is, and then convert that token using our vocabulary into some word that we're going to stick into buffer, and then it returns the length of it. So we can take and we can add to our results the buffer up to that length, which contains whatever word it is that's being returned for that token. Then we set our batch to the token we just returned. We set our position to the next position because we're processing the results in the context. What is the context? We're processing these results in the context, one token at a time. So we have to set our batch to the very next token so that we can process through all the results until we hit one of these end of generation tokens, meaning I could keep going on, but that's it for now.
So in the other example you have with the vision, you have a function called llama batch get one, which takes the slice of llama token. You're not
I think
using.
I probably could have done that also here. I think I maybe could have used batch get one instead of this batch init.
To make that example work, I actually moved llama.decode at the top of the loop, which is interesting, before the sampler call. And then after I got the buffer, I did the batch get one to do the next batch. Oh, and then it decodes it, but at the top of the loop. Yeah. I don't know. I made a couple of
Well,
tweaks to make that work.
well, in this case, it's saying decode the context into the batch. That way, or sorry, reverse. Use this batch in order to perform the decoding on this context, because we set the batch to say, oh, here's the next token, and here's the next position. That way, when we sample it, the decoded results, we can say, oh, and then the result of that is this token. Hopefully that makes sense. So once we've done that,
Yeah,
and
it's
we've
interesting. I had to I changed that slightly when I took that example, but because I don't even well, you're probably doing a little. Well, I don't know if it's that much different because you're doing both.
Hmm.
But if I can I show him what I'm doing real quick?
Yeah, you just switch to your screen
3,
share.
if
4,
I
2.
stop sharing,
No, you
No,
don't have to stop. Can you see
there it is.
that?
wait,
I don't know if you can see that.
I can see it now.
Oh, so this was your vision example, and when we get to that loop, um,
Well, if you could scroll up a little bit, yeah, that's interesting. I wonder why.
yeah, I don't know. I mean, I remember that. Remember when I was getting the panic or something, and then I started looking at other examples you had, and sort of went to this. I already had a batch, so the decode doesn't fail for whatever reason on this first one, and then and I'm able to use the 4 range on the max token there.
Yeah, I mean that I probably can switch my example to do that because I just set like this arbitrary large number, which 2048 or whatever.
Yeah, because you're
Um,
expecting to hit
you
this
can
anyway.
either, yeah, I mean you can either max token, which is, well, I guess it'll keep going until it runs out of memory or it hits the end of generation, or sometimes you'll see people pass in a max token parameter to like a command line program, which
Uh,
it's kind of an arbitrary number.
it's
Like
a
you
very
want it to be
large.
higher, you want it to be a larger number of tokens than however many the end of generation would hit normally,
Yeah, no,
right?
I understand now.
But that could become very large. Like if you're passing in, a bunch of repeated calls as part of a chat or something, or tool calls or something, this could become very, very large very quickly. So you might need to set a maximum number of tokens just because, some practical limits. I guess that's where you started doing the token, the context shifting.
Yeah. Anyway, let me bring it back to where I can never find where he's at.
Just click here
Oh, click here.
and then go to the second screen share.
Oh, it was the same thing. I just have to switch.
There it is.
All right, I put you back. All right.
Cool. So yeah, like in this case, so then we just decode um, the next batch and then go on and process it again. So that's gives us our results, and then we return those, and we just keep doing that over and over. So that's the VLM processing. So that was the last piece. Then again, we looked at Start Web Server. Start Web Server again, the caption itself is served up by this route, which just returns the plain text of whatever's in that captions variable, which is what we set when we got through our loop for the next caption. Those are the results we returned. All right, let's run it so we can actually see it do something.
That was a
Let's
great
see.
walkthrough, at least for Kevin and I, for sure.
All right, I guess we can build it. Keep us honest. Then we can run it. So let's look at our parameters. So our first parameter is camera 2, which should be my second webcam. Our host, we're going to serve it up on port 8080. We're going to use, let's use an even newer model. I have Quen 3, 2 billion parameters. that they just added support to Llama CPP like in the last couple days. So we'll use um, the text model and then the projector, which usually start with the file name, same file name, but with mmproj dash in front of it, and then our prompt, in this case of give a very brief description of what is going on. So if the gods are good, then it's running, and we can see it's processing. Let's go and let's actually look. Um, got a couple unnecessary browser windows. If we go to localhost 8080, there I am. That's me. Hello.
So Ron did this with the
Oh my God.
drone. He did this demo with the drone at GopherCon where it went up and it started looking at people and describing the people that it saw,
Oh,
which
that's
was like
crazy.
mind blowing. Now, let me ask you a question, right?
Wow, that's cool.
Because
It's
this is
just
cool, right? It's giving you a description of sort of what you're seeing. What would be oh, this is take does your CV package oh, it doesn't capture audio. It doesn't capture audio with the video, right?
Um, I don't think so, but like if you wanted to do like closed captioning or something,
Yeah,
sure.
yeah, yeah. That would have to
Um,
be another.
yeah, that would be kind of a different way. Um, it's still running. I just
That's
if I
really
don't,
cool, Ron.
that is awesome.
When you did the
and you can see
you
it's
would
actually doing this at a very good rate of performance, right? Like that's the reason again why I went through all this effort was I needed to be able to get this at a decent frame rate. And the fastest I was able to get things to happen with HTTP calls to Olama was like one every 5 seconds or something, at best. You just couldn't get the throughput because it was just too much massaging of data, to get into the right format, making this HTTP call, waiting for it to get parsed on the other side, you know, versus this where it's just, you know, working with the binary data is as low level as possible.
right, and then ideally, see, this now starts to go back to like what I want to do. It would be great if you could do this on the drone itself, right? If the drone had enough
So the
memory.
drone, I had it actually talking. I was pumping it through a different um, deep neural network to do text to speech and had it plugged into the sound output of my notebook. So it was flying around and then describing in its voice what it was able to see. So
Yeah,
I called it Stochastic Parrot.
but ideally, one day it would be nice if all the processing was happening on the drone and the drone was just returning some form of output with all that,
I could
right?
do that with a lot more expensive drone. The drones I use during my talks are a toy drone where I'm controlling it from my ground station. But larger drones that actually have a single board Linux computer in the airframe, that are fully autonomous, then you run the entire software in the vehicle itself.
There's enough
And
memory and processing power to put the model in there
oh yeah,
like this. Yeah, this just opens up a whole can of worms now.
It's insane.
It's wild, man. Wild.
but yeah, it was really cool to put together this little demo today, just because I was like, oh, I got to have something new to show Bill, and also um, I wanted to be able to show this particular capability since multimodal models are really all about. I'm going to stop sharing so I can hand over um, to you all. But um, but yeah, I mean, multimodal models are about processing video, not just a single image. I mean, it's cool to process an image. Don't get me wrong, but the very next thing you want to do is process, a stream. And right now, doing that in the form of a caption is just the hello world. But if you take a look at, for example, vision language action models, which is like the next level. I did not show that in my talk, but spoilers, that's coming. Um, I have some. I just did not have time in that talk to show everything. But visual language action models, it's the same thing you saw, but it's also an instruction model. So you can give it some instructions and it will look at the image or video and it will look at your prompt and it will use whatever tools and those results in order to try to do the thing that you're trying to ask it to do, which I've really done that not with the vision part. Um, I was flying a drone by telling it, take off, fly forward, fly back, and then turn around, do a flip with my Skynet project, which is written in Bash to control language models with tool support. So obviously, the next step is connect it all together, where the model actually has the camera so it can see where it's going. It's taking your instruction, find me Bill Kennedy in the audience, and then hopefully flies around, finds Bill, or something like that. Lost your audio.
And then you're giving it voice commands. No more PlayStation joysticks, Ron.
I keep that just, that way if I have to take over, assuming, of course, that my override works.
So Florin said for Ron, and make the drone remember the flight path for a return to home mode, or repeat the pattern mode, which then can adapt to the environment it sees around. Yeah, you do all that stuff.
I think you could just tell it where you are now is where you're starting. I don't think you have to tell it specifically necessarily. I mean, that's part of the point of using the video input is that it's able to use that information to orient itself. There are quite a number of models that are fine-tuned specifically around this sort of idea. And if you really want to do it properly, of course, you do fine-tuning and training with the actual devices you want to train for. That's what I don't have any of it set up right now, but I've got some robotic arms. I don't think I can. I can show you like the box. Um, I've got these robotic arms that I've been working with. Everything's all put back right now just because I was making a mess. But a lot of times, the way that people train robotic devices is through imitation learning. You show them how to do it. It records that in some fashion, right? Maybe it records the list of commands you sent. Also, maybe associated with the video stills for each one of those points in the process. So then that's your training set, and you take whatever vision language action model base and then fine tune it using these images and these commands and these outcomes. That's the model that you would
I'm
then want to
assuming
use.
I'm assuming the Neo company is doing exactly that.
No, Neo has actual people doing remote control.
No, but then
Neo's tough.
recording all of that as training data, right? Eventually you don't want the person controlling it
Maybe
anymore.
we'll get to that. Maybe they won't. I'm not sure how I feel. Like, I think like humanoid robots are really fun looking, but not really very practical in real terms. Like
Oh,
all the actual useful robots I've ever used did not look humanoid. It's just like an arm, or like a cart with like a grabber, for like material handling flow in a factory. You don't need humanoid robots. What you need are like little ATVs that have like a winch on the back with the special attachment to pick up, in this case, it was rolls of foil that were going to be used to manufacture lithium polymer batteries. These are big, heavy rolls. And also, you must be really gentle. Tiniest little defects from mishandling these rolls means you have to throw the material away because if you make batteries out of it, those batteries are going to be very volatile. So, these material handling robots are not just like throwing the rolls around. They got to like very gently pick them up, move them over, very gently put them on to the place of the next machine. You know, these are not humanoid robots, but they're super useful just because it's really hard for people to even do this because you're like, oh, shoot, I screwed up the roll because I picked it up wrong.
so you don't, maybe not in our, though I would imagine in our lifetime, you don't expect these initial Neo robots to have any real capability or function in the home without an operator?
Well, first they have to actually ship a product. Then we'll see what it ends up being, and then we'll see how far they get. Um, I wish them the best. Don't get me wrong. Like, I totally want to see people succeed. Also send me your robots, people. Send me your robots.
What about he worked?
But I don't know.
Ron worked
Sorry,
on
go
all
ahead.
the Star Wars stuff,
Oh.
so which he couldn't tell anybody while it was going on.
Mm-hmm.
But what about R2D2 type of robots at that point? We're a little more
Well,
generalized.
you know, most of the robotic devices are really specialized. Toy robots are just like fun to play with. Like nobody's really hit it with a home robot. I mean, the most successful home robot is Roomba because it has an actual purpose.
I
Now,
love my Roomba. Yeah, I mean it's badass.
but I do want to say the robot revolution is here. Here's how I know. Okay. My wife Ava has two robots now. One which does floors and one which does windows.
Whoa,
All
time
right.
out. You got a window robot? What
I
is
have a
that?
window robot.
I don't
It
understand that one.
I haven't seen that.
it has a very powerful vacuum device, so it sticks to the window and it rolls around and cleans the windows.
What is that called?
I want to say Hobot. I'll have to look it up.
Hold on.
Now, my wife is not a technologist. Bill knows
Okay.
my wife Ava. She is absolutely not a technologist at all. Quite the opposite. She's a creative. And when she has
Maybe more
gotten two
suggestive.
robots in the last like 6 months, it means it's mainstream.
Wow, that's crazy.
So, yeah. But these are not humanoid robots, and they have a very specific purpose. And um, some of them you can actually like reverse engineer, some not. There was a pretty cool post on Hacker News recently about that. Um, something I did. I didn't trust my home vacuum, so I reverse engineered it or something, some kind of clickbait title like that. Naturally, I was like bookmarked it because I'm like, note to self: check Bluetooth protocol of Ava's robot. But
Can I use this on the outside or they're just for inside? My windows get it dirty on the outside, more on the
oh no,
inside.
you can put them on the outside. It's just you have to, when they beep, you got to take them off and put them on the next window. But no, they work quite well.
How much? $400. Dude, why am I just hearing about this now? And then Floren's like, yeah, they're fun. I want to strangle Floren for not telling me about this. Okay,
Yeah,
so she's
well,
got these two robots. Wow.
but neither one of them is at all humanoid. Um, I mean, I saw the Neo thing, And it made me think of the Tesla robot announcement, you know, which again, like, I wish everyone the best of luck. I totally want to see robots, but I also know from practical experience and also seeing like very serious people like Rodney Brooks, creator of iRobot, like, these are like much more serious roboticists than myself. I mean, you know, like I, but at the same time, I'm still waiting for delivery of my robot from Hugging Face, my Ricci. I'm still a believer,
What is that?
but
Hmm.
so Hugging Face purchased a robotics company, um, I want to say around the beginning of the year, called Pollen Robotics. If you look at Pollen, yeah, yeah, that's it. That first one, um, that's the one that you could get, maybe. Well, if assuming they ship it. Um, that was actually the robot I was hoping to bring with me to. Well, first I was hoping to bring it to GopherCon. Didn't ship because it was supposed to ship by end of summer. So then I'm like, oh, no, cool. Maybe I'll bring it to GoLab, but then didn't ship. I did get an email saying shipping in October. I haven't gotten it. Um, but again, this is not a diss. It's more, wow, it is really hard to ship a robotic product. Having actually done some of this, you know, quite a bit,
Is the
like quite
idea
a
of this
bit.
robot like it's a fun interactive robot, but will it take over Alexa's job? Like you can tell it.
Well, that's kind of their idea, but if you look for their bigger robot, like their main robot, because the Ricci Mini, I think it's just maybe the Ricci.
They
Um,
have this list of Mini Light and Ricci.
Not the Mini, but they have like a full size one.
Oh, they do.
That's why I got the arms. Um,
Uh,
was but yeah, that one is like 10,000 US or something, and I don't know when it's shipping. Like I really don't. Um, Next year maybe.
okay.
They
Yeah, I
have some
can't
really
find it.
cool looking videos that are super intriguing. And Hugging Face is a very cool company that has a lot of credibility.
These are robotic models. Oh,
And they have been doing a lot of, Pollen's been doing a lot of interesting stuff for a while. That's where
huh.
this whole the robot thing is coming from. And you can see vision language action models. So this is what I'm working on right now. So hopefully the next time we get to talk, I'll be able to show you some of this stuff actually working.
Yeah, that would be cool. Oh, this is the bigger one.
Yeah,
I gotta save these
and they
links.
have
That's cool.
they have these they have a hand design as a separate sub project. And all the stuff is they all the 3D models are available. You can 3D print it, and it'll take you a million years, um, and a lot of PLA, but
So
and a
you,
lot of expensive servos. I mean, one thing is all of their stuff use these high-end stepper motors, not just like cheap servos, you know, which are actually each one of these is individually a serial controlled device with a unique set of capabilities. That's where like one arm is, 12 servos or something, 16 servos. So it takes a lot of amps and a lot of coordination to do the inverse kinematics type of algorithms. Inverse kinematics is my arm is here and I want it to get there. What are all the motions of all the different stepper motors so that my arm ends up in this new position?
it
So there's a
sucks
bunch of,
that they went right with just Python. Like, which I guess there are C libraries in.
well, there are people doing this in other languages. I think. And I'm not the only one. Okay, there's a bunch of others. Um, more about that in the near future.
So,
But
so this whole robot is really
anything you
about,
could do in Python, you could definitely do in Go.
yeah. But this whole
And with
robot
better,
is really about controlling the arms, right? Having the arms do things.
I sent
a
you a
lot of it
link
is about
Florin
that.
wants you to open on Slack.
Well, I mean, there's different. Um, you want it to do some type of useful work,
Yeah.
right?
You just saw it
Like
in my
what
chat.
that could be. It could
No,
be,
no, my
you
chat
know,
with you.
picking up something and putting it
My
somewhere.
DM.
Like my material handling example from the factory.
Hey, Ron, Florin told me you need to look at this. For $1,000, for almost, what is it? Let's just say 1,200 bucks with tax. You can have your own robot dog. Look at that, Ron.
It's a Jetson Nano, which is like a very underpowered device with modern requirements for
I wonder
doing
how
the kind of
big it is.
stuff you want to do. Like the latest devices
Oh, it's small.
from Seed Studio, it's like $1,000 just for the small form factor PC with the GPU. I want to say the NVIDIA, is it DGX?
I don't know.
I want to say DGX. Yeah, yeah. DGX? No. Um, it's the latest one. Is this the one? I thought that was it. Yeah, here we go. Yeah. NVIDIA DGX Spark. That's anybody who's listening to this ever, send me one, please. So you see,
Four
just that,
grand. What is this for?
just that, it's
Oh,
just that, no, it's not that notebook, it's that little box next to it.
Yeah, the
That thing.
oh, it's
Right,
that.
it's that
4 terabyte.
yeah, right.
Uh-oh. I shouldn't have shown this to Florin. He's going to want to buy one.
Well, so you see, like, cute robot, but I did CPU and GPU that are like four of those, five of, whatever, just because you probably need to add some memory. I mean, you always need to add memory. So yeah, if you want to do this stuff at scale, meaning fast enough to actually move the device along, and do anything at all useful, which means also multiple cameras generally, right? Like a stereoscopic camera for orienting it, and then cameras on its grippers. That way it can see what it's picking up. And you can see where you need quite a lot of horsepower in order to process these three different video feeds quickly enough to do, um, you know, uh, quick enough to be able to orient it so that it actually picks up the right thing. I mean, fast enough to be useful, right? Because I mean, it's got to be better than a person, and we just get people to do it.
Look how sad this is. If you can only afford one arm.
That's not sad. The sad part is you can only afford the arm, not even the body. Like right now, I have arm. I have one arm.
You
Okay,
have
no
one of
body,
these
just an
arms.
arm.
You have one of
I
these
just have
arms.
an arm. I have what's called the SE 10 or SO 101. If you look up for the
Wow.
SO 101, I believe it's SO 101.
Where do you
Is
want
it
me to
SO?
search the internet for that?
Yeah, SO
SL.
101 arm.
No, you don't have that. I said, oh,
Yeah, no,
that's
that's what I
SL.
have.
Oh, this is what you have.
Yeah.
Nice.
One is the arm. The one on the right is the actual arm. The one on the left is the thing you use to train it. Remember, I was telling you about imitation learning.
Oh,
You want to like show it what to do.
that looked like a gun to me. I was like, what is Ron doing? Doesn't that look like a gun?
It's a pistol grip.
Yeah.
I was like, whoa, that's wild, man.
Yeah.
You're
So
having
this
too
is the
much
stuff.
fun, Ron. That's all I'm gonna say.
Well, I mean, there is purpose for all this. It's not just playing with toys. I mean, you know,
Wow.
I've spent many. I spent a lot of time the last 3 years in factories. Let's just say.
So let's say you bought this arm, but how does it come with some drivers, some APIs, and C? Like, what do you get when you buy something like this?
You get a box of 3D printed parts, a couple boxes of stepper motors and wires and stuff, some power supplies, and a smile.
And what,
You
a
know,
serial interface that you have to code yourself?
well, I mean, you can use. I mean, there's a bunch of software already out there. Um, Hugging Face has the whole Le Robot data set, and there's a bunch of companies and projects that use that data set for either fine tuning a model, like what I was saying before about, okay, I'm going to teach it how to, pick up a chess piece and move it on a board, for example. So I have to show it how to pick up a chess piece. This is not how to play chess. This is just how to actually have an arm reach over, pick up the right piece, move it over to the right location.
Wow. Okay. I mean, yeah, you're starting from scratch at that point, though.
Right, but there's a lot of data sets already set up around certain activities and things that are geared up for you to be able to do the fine tuning, and then you can build your own policy model. A policy model in robotics is like the control model. It's like the high level one, the one that figures out, here's our plan. We go here, we do this, and we do that. Because you have all these other models that are doing individual things, like the model that knows how to pick up a chess piece, and then the model that knows how to, navigate the robot around the room without knocking into anything. So robotics is really a whole bunch of models all combined together to do different specialized tasks, which are then being controlled by some type of policy models. Policy. I'm not really sure why they call it that. It's probably something to do with factory control systems, just having to do with like what is the robot allowed to do and not do. And again, it's harder to understand that when you're looking at a humanoid robot. It's a little easier to understand if you're looking at a robotic device where all it does is um, roll out some foil, and then these big blades come down and chop it into small pieces. And you have to make sure that nobody's in the area where that is, or they get pieces chopped off of them, what's called an interlock. So when they say robotic policy, quiet, that's not the puppy, that's my other dog. I'm saying I have to get off this call soon. He's he's mad at me now. But but this is really the cutting edge of what's happening in robotics is both doing the fine tuning around individual hardware components and then generating and fine tuning the policy models that actually have devices do some useful task. Robotic delivery, moving things around inside the factory, putting out a fire, whatever the thing is that you're trying to get it to do.
Yeah, it's wild. All right. Well, we
And
are at
this
the.
this stuff is working. I say this because my wife, the technophobe, has got two robotic devices cleaning up. Not right now. Right now, she's playing with the new puppy. But so the robotic revolution is here. If anybody who's watching this takes only one thing, it's you can do this with Go, and you should.
And thanks to all the work you're doing, you're making it really easily accessible from Go too. So especially this Easma now that we can run basically any model we want embedded. in any Go program.
You can see where an ISMA model, that's a vision language action model, similar to the demo I was showing with OpenCV, is just connect that up to some of these stepper motors, and there's your robotic control system as a standalone Go
Demo
program.
link.
Yeah, that's it right here. Hold on. That was the, I'm going to drop this. Everybody wants this in the link. Hold on. Well, Ron, I appreciate the 2 hours that you have. Let me get back over here. I appreciate the 2 hours and demoing that and going through those APIs, because Kevin and I now have a much better understanding of that. And for what we're trying to do, which is a single binary with both embedding and large language model for one specific RAG app that we can deploy even in Cloud Run. That's like our goal. And then the only thing you have to do is change out the data set. Like the rest of the code is pretty much the same once you sort of have it. And that's pretty wild, I think. Just don't need, I can now deploy these systems that I would need Kubernetes for, because you got to install the model server and you got to install this. And even the web API that we're going to build will all be embedded in one sort of binary. But I couldn't have done that without ISMA. So thank you.
I live to serve, my friends.
Yes.
Yep.
All right, Ron, I appreciate it. We've dropped the link to that demo and everybody's seeing all the stuff I'm doing with your stuff. So I really appreciate it. I know it's a little bit late over there too. So go enjoy your new puppy, Ron. Good.
Yeah, I'm gonna go see
Congratulations.
what he's described. All right, thanks a lot, you guys.
All right, man.
Good to talk to you.
Bye.
Ciao.
All right. So I think that's it for today, bro. And then tomorrow, on Thursday, we'll continue with our little project. But I think we have a better understanding of the APIs now. So
that
that's,
demo was so cool.
Yeah. And going through it was good. All right. We'll see everybody Thursday.